Okay, let's do linked list cycle next. Given head, the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pause is used to denote the index of the node that the tail's next pointer is connected to. Note that pause is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise return false. Then there's a couple of examples. So this one's pretty simple. Anytime you're doing anything with a linked list that's not just like adding or removing things from, well, basically from the end. Well, if you only have the head node, then only basically adding or removing things from the very like first node actually is going to be linear time. So if you only have the head, you can say prepend stuff in constant time. You can remove the head in constant time, but that's about it. Everything else is going to be, so we don't know where this loop is going to start. 2 could be 4, -4, maybe this -4's next pointer is itself. It would take all 4, it would take linear time to find it at the very end. So our target runtime is going to be linear. And then we're going to be able to achieve constant space here too. And that's, so it's going to be linear time, constant space, and I'll show you why the constant space. Well, realistically, like I think it'd be hard to make this one say like linear space or anything worse than constant space. So let's do it. First we'll check for edge cases. So it's a pointer that's passed in, so we'll just check if it's null, I guess. So if not head, return false. All right, that's just the basic edge cases. So then we're going to need a main loop, and we're going to need a couple of pointers. So we're going to need it's going to be a 2-pointer approach, a fast pointer and a slow pointer. And generally, what I mean by that is we're going to have 2 of them. So one starts here, one starts here. The fast pointer will increment 2 times at each step, and the slow pointer will increment 1 time at each step. And the reason for that is we're going to have them both go along the linked list. And if they enter, say, a loop, so for example, we'll have slow here, fast here. On step 2, slow is going to be at 2, the fast pointer is going to be at 4. Step 3, the slow pointer is going to be at 0, and the fast pointer is going to go from 4 to 2 to 0. And we'll see that they collide. And given that one is twice as fast as the other, that we expect the fast pointer to traverse a loop at most twice if it exists before it collides with the slow pointer, basically. And that has to do with overlaps of circles, and it's definitely going to happen. It's not going to be, say, like quadratic time. It's going to be linear because it would happen at most after 2 circumnavigations or 1 of the slow pointer. So 2 pointers to start out with. List node slow equals head fast head next. So while they're not equal, actually we want to check for like null next pointers first. So fast one is always going to be ahead. So we're going to say while fast next. And this is going to jump twice. We want to see if there's actually 2 steps ahead. Because if there's not, then there's no loop. And we know there's not going to be a loop if there's ever a point where there isn't a next and a second order next. Next. And then lastly, we do want to break if they collide. So either they reach the end of the linked list or the 2 pointers collide. And that would be another exit case is what we want to check for. Slow does not equal next. And then we'll just increment the pointers, basically. Slow equals slow next. And then fast, fast next. And that's it. And then so we do want to actually check if they're equal. So if we break in one this case or this case, then there's not going to be a cycle. If we break in this case, then there is going to be a cycle. So we just we check if they're equal again. Oh, yeah, that is, let's fix that. Slow to not equals fast. Okay, that's better. So then runtime, I'll do runtime and correctness, and then we'll do an example. So it's going to be O of n time to find the end of the list, or the fast pointer will circumnavigate at most twice before the slow pointer. And then it's constant space because we're using 2 variables and that's it. And then they're probably either 32 or 64-bit. It depends on the language implementation. I think, well, oh, no, not the language. It depends on the address space of the machine. But either way, it's going to be constant space for whatever machine you use, because I doubt they're going to use huge, gigantic numbers for their address spaces, because there's a constant amount of memory period or storage, or however much storage there's a constant amount of it to pointers. All right, so we already stepped through this example. I guess this one's gonna have no cycle because one's null. So we start slow here, fast here. 1 increments once, 2 increments, 1, 2. Yeah, this one's works for this, it works for this. And then if this one, so there is no fast next. So fast is going to be null. Oh, that might actually throw an error. Hold on, let me think this through. Wow, fast and fast next. So hit fast is going to equal null, so it's going to throw an exception if it hits that next. I'm going to just add that as another edge case, not head or not head. Okay, check for syntax errors. What? Oh, I didn't increment fast twice. That was important. Okay, so there, submit. And boom. Rankings don't matter because it's a web-based execution environment, so that just varies all sorts of crazy amounts. Check it off, and we're done.